Can you imagine how it's powerful right now? So right now you have a microstrip feed network that you can change any of the parameter, and the other parameter is gonna change in respect to it. Welcome everybody. Feed network or power divider are designed for distributing the power or input signal to each element or to different devices. So in the case of microstrip power divider or microstrip feed network, they can distribute the power, or based on the length of the each element, they can even create a phase shift in the final signal. Here I want to show you how you can have a very good design based on the parameters, that when you want to change one parameter, one length or one width, the other parameter is gonna affect, and they are gonna change in respect to the parameter that you want to change. Here I use the CST microwave software, but you can use HFSS. Both HFSS and CST have the same performance and same result in this design. The main thing is that you know how you can use parameter in your design. By choosing brick, double click, double click, double click, first we design a substrate. It's a start from with 0. The length of the substrate is LS. The width of the substrate is equal to minus WS divided by 2 up to WS divided by 2. So the S is referred to substrate. It's a start from W equal to 0 up to minus substrate. I choose the material. I just press R that I go to the Rogers family. I want around 2.2 epsilon Rogers RT 5880. So when you press the previous, it wants you value of the parameter that you gave to it. For WS, I just define as 160, and LS equal to 63. Our unit is millimeter, so it is equal to 16 in a 6 centimeter. So the substrate thickness is equal to 0.8. For the back side, we need a flat copper sheet, so I just press D, and after that S is for select in the CST, and double click on the background of it. So I choose the brick, and I can just put the value that is here, but I want to use the parametric. So here we have the value of the ground and the value of the substrate are equal. So it start from minus WS divided by 2 up to WS divided by 2 LS. So it start from minus substrate minus T. I just consider the thickness of the copper is equal to T minus substrate. So for the T, I put 0.04, and the material is copper. So we get the preview, it's good. And then Parametric. So then we are going to the main section that is designing the microstrip line. Here I choose the brick. For the very basic and main microstrip feed line, I consider the W of each step with 1, 2, 3, 4. So the first one, I consider the width of the feed line as from minus WF divided by 2 up to WF divided by 2. So the WF, actually WF1. So the WF is referred to the width of the feed line. So don't don't consider it as a bad word. So we don't have t in this word. So it's from minus wf1 divided by 2 up to wf1 divided by 2. And then it starts from 0 and it goes to up to LF1. And the thickness is equal to T because it's copper. The WF1 I consider 2.49 and LF is equal to 10.8. Okay. And then this main feed line is gonna divide into two sections like this. The thickness is T. In the direction of U, which is in this direction, so it's gonna be the length of the second microstrip line. So here I just consider it as minus LF2 divided by 2 up to LF2 divided by 2. And in the V section, it starts from the end of the LF1, which is here. So we have LF1 plus, and the width of the second microstrip line should add to it. So I'm gonna add it from the second one. So it's a start from LF1 plus WF2. For LF2, I put 72.67. For the W, I put 0.72. So you can see it's a start from here. Okay, and then here, this line is bending like this. So in the U section here, from the UM max is to start from LF2 divided by 2. This is from here. For the width of it, I just reduce the amount of WF3. I consider this line as a 3. So for the WF3, I just put the same amount as WF2 because I want to make it simple. And then in the V section is to start from VM min, which is equal to LF1 plus this section plus this section, which is WF2 plus, no, not plus, WF2, which is goes there. On the other side, I just copy and paste it. We have plus the LF3, which is the length of the second one, this one. And the thickness is equal to T. For the LF3, I put 4.50 and it looks like this. You can see how exactly it's gonna connect to it. Then we are gonna have the same scenario here as we had here. This should divide it into 2. Alright, we are going to the section 4. So, but here is a little bit tricky. For the U, I should put the length of the microstrip line. But first of all, I should find the center point, which would be here. Okay, center is exactly here. So how can I find the center? It's equal to LF2 divided by 2, which would be end of this one, minus WF3, which is the width of this one, but divided by 2. Remember, the LF is total this size, which half of them would bring us in this section, and WF divided by 2 is gonna reduce this amount that we are exactly here. So if I show the previous, you can see it's gonna exactly start from the middle. So this is our benching mark. So for the other one, Ctrl C, Ctrl V, I just copy and paste it. Now we can consider minus LF4 divided by 2 and on the other side we have plus LF2, LF4 divided by 2. So in the V section, which is in this direction, where this line is gonna start, it's gonna start from LF1, we go up to there, and then we should go up to there plus WF2, right, plus the length of this line, LF3. On the other side we have that one, and we add the WF for it, which is for this one. The thickness is equal to T. Let me see the previous. The LF4 I just consider as 35.96, and WF I put 0.09. It is just a sample, or maybe one. So the amount that I put is a sample. So then this line is gonna transfer into U Junction, which is here and there. So I just go for one of them, and we have a junction like this. Where is the U center of this one, which is starting this direction? So we have to find this point. Okay, so we are going up to LF2 divided by 2. You can see how I start from the beginning and build it up. So you should never ignore the basic parameters that are here. LF2 divided by 2 brings us here, and then I'm gonna reduce this amount minus WF3 divided by 2, so it brings us here, and then we are gonna add the LF4, which is the length of this line, plus LF4 actually divided by 2. Alright, you can see how it's start from here. So on the other side I just copy and paste it, and the only thing that I need, reduce the white of, we are going to the 5, WF5, which is here again. I consider as the same previous one for simplify it. Alright, and then in the V section we go from there, LF1 plus WF2, white of this one, plus the length of this one, LF3 plus WF4. I just put some of them close. I should add plus. So I consider the thickness is equal to T. You can see how it's start exactly from it. Alright, I just copy and paste this one, and I add the LF5 to it. Put 2.32. And then, because it's symmetric, you can only design one side of it, and then you can kind of mirror it on the other side by the software. I'm gonna tell you. So here I just put the final fit line, which is gonna connect us to the radiation patch or SMA connector. It depends on your application. The U of this one is a little bit hard, but the thing is that because I'm going to teach you, I'm going to go step by step, but you can copy and paste the U of the previous one in this one. So the U starts from this length, LF2 divided by 2, so it's bring us here, minus LF minus WF3 divided by 2, and then we are here, plus LF4 divided by 2, so it brings us there. Then I should reduce this amount minus WF5 divided by 2. Oops, it goes exactly in the center. You can see if I put 1, exactly to start from the center of that one. So then we can copy and paste it. So here I just use parameter for everything, but in your design you can consider some of the parameters equal to each others, and you can eliminate some of the parameters. For the width of this one, I just reduce WF6 divided by 2, and the other side I add plus WF6 divided by 2. For the WF6, I just consider 0.45. Then for the LF6, we'll start from here. So we go LF1 plus WF2 plus LF3 plus WF5 plus LF4. So it should bring us in the starting port here. And then for the other side, we have the same plus LF6. I consider LF6 11.41. All right. And start from 0T. That's all. So for the other side, I just gonna do the same. LF2, LF2. WF5, LF1 plus. And then for the read section, we have LF1 plus WF2 plus F3 plus. All right, so this one is the same. So once we design one side, we can kind of mirror it on the other side. It's like this one, this one. I'm just pressing the control on the keyboard. And then double click, double click, double click, double click. Then you can right click on them and then you go to the transform. You can do the same thing for the other side, but it's easier to do the transform. So we choose the mirror for the plan of u equal to 1, and we choose copy. It should be the same. Yes, this is the same. So here you can see that I create a feed network. So right now the main signal is coming and it's gonna distribute in a form. But based on frequency that you have, based on substrate that you have, based on anything that affect your project, you can change the parameter of it. And you can see how cool is it. I'm gonna show it for you. Then imagine that I want to change this length, okay? This wide, I want to make it bigger. So this is the second, so it's LF2. So I'm gonna change it and I hope it works well. So it should also change the place of this one and this one and this line and all the section that's connected to that one, and not gonna affect this main feed line. So I go to the home and then parametric update. Ooh, you can see I can do anything that I want. So I can change the width of this one, which would be WF. 1 2 3 4. I can put it as half. Look, WF, I can put it as 4. So for showing it better to you, I'm just make the line a little bit wider. All right, the line is wider right now. So now imagine that I want to change this line, which would be 1 2 3, the LF3. Look how fast is it? It's gonna cool. For example, this one, 1 2 3 4. For LF4, I put 40. And when I update it, it's gonna update everything. So can you imagine how it's powerful right now? So right now you have a microstrip feed network that you can change any of the parameter, and the other parameter is gonna change in respect to it. You can optimize it, you can do a lot of things. So you can optimize it in the case of power that's gonna transmit it, in the case of phase, in the case of matching. That's very cool. And for showing powerful thing that we have right. So then as a sample, I just put 4 radiation patch. So then the whole of it act like the array antenna. And in this section, we don't want to really design an array antenna. I just want to show the application that how much it's powerful. So at the 5 gigahertz, you can see how much gain that I can give. And this is the directivity. So 12.5 dB gain I can get from this one because I used the RA1, and then you can use it in the different application. These are some basic structure that I think all the people who work in the RF and microwave should have it, because then you can change the parameter and you can redesign this one for the all of the frequency. Right now I can change the length and width of the every single line in this design, and I can adapt it with any frequency or any substrate that I'm working with it. Thank you very much. I hope this is useful for you.